Hello! Over the course of this video, I'm going to show you a reformulation of quantum physics that is superior in every way to that which is accepted by mainstream academia. I'm going to do this by making a few inexplicable assumptions about energy, and by following these assumptions to their logical conclusions, I will, among other things, derive the periodic table of the elements and its properties. So let's get started. First assumption is that energy and all of its properties can be described by a hypothetical particle, where we have an example shown here. These particles have associated with them an intrinsic velocity that is going to cause them to continually displace throughout space, like so. Each of these particles also has associated with them three different acceleration fields that will act on each other's intrinsic velocities to change their orientation without actually changing their magnitude. Here we have a displacement vector r1, at the end of which we place another particle p2 with its own intrinsic velocity v2. The first acceleration field is denoted by green. We call it a1, and is computed as the cross product of v2 and r1. What's going on here is we're computing the a1 that is created by p1 that is acting on p2. We can imagine that this a1, following the right-hand rule, will appear here, and the effect that it's going to have on p2 is it's going to cause it to orbit around p1, like so. The second acceleration field is denoted by red, and is called a2, where a2 is computed as the cross product of a1 and r1. Once again, this a2 that we're computing here is the a2 that is created by p1 that is acting on p2. Following the right-hand rule again, it appears down here perpendicular to a1. And we can see that the effect that a2 is going to have on p2 is that it's going to cause it to orbit around p1 along a perpendicular axis of rotation. The final acceleration field, a3, is denoted by light blue. It's computed as the cross product of a1 and a2, and it's a bit hard to see, but we can see it pointing from p2 towards p1. Now I haven't actually animated the effect of a3 on p2, but we can see that what's going to happen is it's going to pull these two different particles together. Now I discovered that if you superposition all of these different acceleration fields on top of each other, and then simulate the effect that they're going to have on each particle in a system of particles, what will happen is that if you have the correct initial conditions in terms of the placement of the particles relative to each other throughout space, and the orientation of their intrinsic velocity vectors relative to each other, you will create a stable periodic geometric structure that you can use as a building block to recreate all of physics. Here we see the initial conditions that I used being constructed. The initial conditions that I used are just two concentric rings, with all of the velocity vectors of each particle all pointing up. Now the number of particles within each ring doesn't really matter. You can have as many as you want, as long as the number in each ring is equal. Where of course we would calculate the position of the jth particle throughout time as being the integral of its velocity. Velocity itself is time and distance dependent. We compute the velocity of the jth particle throughout time as the integration of the superposition of the three acceleration fields created by every other particle in the system, as shown in this math here. I've normalized the magnitudes of all of the different acceleration vectors here so that they are each a distance-dependent scaling of these separate alpha constants out front, alpha 4, alpha 1, alpha 2, and alpha 3. A1 and A3 scale in direct proportion to the distance of separation between particles. The further two particles are apart from each other, the stronger their A1 and A3 acceleration fields will affect each other. In practice, this is actually unrealistic. We have to limit the effective range of A1 and A3 by defining it to be zero outside of a distance of R0 from any given particle. A2 is inversely proportional to the distance between particles and is not restricted like this. We integrate these acceleration fields to find how the orientation of each particle's intrinsic velocity changes over time, while restricting the magnitude of those velocities to always equal alpha 4. However, when we integrate velocity to find a particle's position throughout time, we don't just integrate this intrinsic velocity, but a superposition of all of the particles' velocities that is inversely dependent upon the distance between them. If we start with the initial conditions of two concentric rings of particles, with all of the particles' velocity vectors pointing up, and run a simulation of this system, we get the following result, which I'll open in another video here. What is occurring is our two concentric rings are rotating to the right and leapfrogging each other, such that they both travel upward at an approximately constant average velocity. The leapfrogging of the rings is caused by the orientation of the intrinsic velocities of the particles oscillating between being vertical and horizontal. If we skip forward in time, we can see that this behavior eventually falls apart. This is not due to it being unstable, but due to the slow accumulation of error by the discretization scheme that I used to construct this simulation. By tracing out the path of these concentric rings, we can create this sequence of alternating cones. The system of particles that we have simulated is similar to the classic problem of a system with three gravitating bodies, such as the Sun, the Earth, and the Moon. Trying to solve for the time-dependent position of each under the gravitational influence of the others creates a nonlinear system of differential equations that has no analytic solution. This is a common feature of systems of differential equations that are nonlinear, forcing people to construct similar simulations to understand their behavior or use something known as a phase flow diagram. A phase flow diagram is a plot of the variables and the derivatives in a differential equation that create a vector field that show how different initial conditions will flow either towards stable points or away from unstable ones, thereby giving a qualitative description of how solutions to the differential equation behave and what forms they can take on. We can create such a construct ourselves by letting the number of particles in our concentric rings go to infinity as well as the number of concentric leapfrogging rings themselves. If we do this and then average out their positions over 1/2 period, we'll get a continuous cone-like geometry. Like so. That will have our acceleration fields distributed continuously throughout its volume. This is the geometric building block that we will use to reconstruct all of physics. The acceleration fields are distributed throughout the cone like so. Green A1 curls throughout the cone according to a right-hand rule. If we curl the fingers of our right hand, they will curl in the direction of A1, and our thumb will point from the base of the cone to its tip. Red A2 is distributed like this. It fountains out of the tip of the cone, comes down the sides, and goes in and up again at the bottom. Blue A3 is convergent everywhere on the cone's central axis. All of these acceleration fields superposition to give the entire geometry a net average velocity pointing from the base of the cone to its tip. We will use this geometry as a building block to construct larger fractal representations of it that we will use to model all of physics. But first, in order to construct larger geometries, we need to define an opposite polarity energy particle and an associated opposite polarity cone. We do this by reflecting a red cone that we will call positive through itself and changing its color to signify the change in sign of the cone and its A1 acceleration field. We will call blue cones negative. As red cones follow a right-hand rule, blue cones follow a left-hand rule. The rest of the acceleration fields of an isolated blue cone are the same as a red cone. However, when a red and a blue cone overlap, or their constituent particles get close enough to interact with each other strongly, the acceleration fields affect each polarity of particle differently. Now we will see the acceleration fields resulting from overlapping a red and a blue cone from the perspective of the red cone's particles. A1 superpositions linearly. Because we have a right-hand rule cone overlapping with a left-hand rule cone with opposite orientation, the A1 acceleration field is stronger within the region of overlap of the two cones. Due to the difference in polarity between the interacting cones, the A2 acceleration field of the blue cone has its direction of circulation reversed from the perspective of the red cone particles. A3 superpositions linearly, just as A1 did, becoming stronger within the region of overlap. The net result of overlapping a red cone with a blue cone is the creation of a net velocity for each cone that converges on the region of overlap. The interaction is symmetric from the perspective of the blue cone's particles. A1 and A3 superposition linearly. However, the blue cone sees the direction of circulation of the red cone's A2 acceleration field as being reversed. The symmetric interaction between the red and the blue cones causes the red cone to want to be accelerated into the blue cone and the blue cone to want to be accelerated into the red cone. This is one half of the law of interaction that these cones are subjected to. Opposite polarity cones attract, similar polarity cones repel. For two cones of equal polarity, the net result of overlap is the creation of velocities for each cone that diverge from the region of overlap. The interaction is symmetric from each cone's perspective, and the same if we have blue overlapping with blue. For A1, we have a right-hand rule cone overlapping with another right-hand rule cone with opposite orientation, resulting in cancellation and a net A1 of 0 in the region of overlap. The direction of circulation for A2 of each cone remains unchanged from the perspective of the other cone. While not explicitly shown here, A2 is also 0 within the region of overlap. We know A2 curls like this. The non-overlap region of the cones acts to pull the particles in the region of overlap up and out, changing the orientation of each cone and its net average velocity. This is possible because A3 is also 0 within the region of overlap. The net result is to create a divergent velocity for each cone that diverges away from the region of overlap. The law of interaction allows us to glue oppositely colored cones together into larger geometries that are fractal representations of a single cone. The larger geometries have the same net distributions of acceleration fields. A1 curls like so, causing the entire structure to rotate. If it rotates incredibly fast, from our perspective, this geometry will be indistinguishable from a single red cone. A2 curls the same way as it did for a single cone. It fountains out of the tip, comes down the sides, goes up and out again at the bottom. A3, while not shown, is once again convergent everywhere on the structure's central axis. Each subcone has a net average velocity, with 3 pointing up and 1 pointing down. They superposition to give the entire structure a net average velocity equivalent to 2 times that of a single cone. There are 2 possible fractal tessellations of red and blue cones, a right-handed net red one and a left-handed net blue one. What we've essentially done is use these particles to build a model for the kinetic energy of matter in motion. But this model is incomplete. To complete it, we need to define what mass is as well as matter. We'll deal with matter later. For now, let's define what mass is. This equation describes energy as being equal to mass times the speed of light squared. The speed of light, being a velocity, has the units of meters per second. We will reinterpret this speed of light squared as being the second-order derivative of area with respect to time. If we rotate this triangular geometry, we can see that there is an oscillating total amount of area in the plane that we are viewing it, which we define as a reference plane. Because our larger energy geometries rotate, they too have an oscillating total amount of area within a reference plane. Thus, we define the mass of a geometry as being the amount of energy in that geometry divided by the second-order time rate of change of area. We will now greatly simplify our subsequent analyses by extracting a two-dimensional slice from our 3D geometries and defining it as a single quanta of energy. It has all of the same vector fields as our 3D geometry, except they are now in 2D. Our 2D quanta of energy is an equilateral triangular coin, with a separate polarity on each side. The polarity that actually interacts with other overlapped quanta to produce forces is whatever side is facing up. The equivalent operation in 3D to flipping a 2D quanta over is reflecting a cone through itself. These quanta create varying total amounts of energy by coming together and coming apart in odd-numbered jumps. There is always a total square number of quanta in each fractal triangular geometry. This restriction is this reformulation of physics version of quantization. Because quantization in this form is at its core a geometric constraint, we can rescale our quanta to create continuous distributions of energy that are still subject to the law of quantization. We have previously defined our quanta to obey a law of interaction, similar to how electric charges behave, but this particular diamond geometry is how we define the electrostatic fields of charged particles in this reformulation of physics. In this reformulation of physics, the A2 acceleration field is what electric fields are made of, and the A1 acceleration field is what magnetic fields are made of. In the standard model of physics, electromagnetic fields obey the law of interaction and are described by Maxwell's equations. A curling electric field will induce a time-varying magnetic field. A curling magnetic field will induce a time-varying electric field, as well as a current. If the induced fields also curl, the electric and magnetic fields are mutually inductive. In our reformulation of physics, A1 and A2 have been defined as being mutually inductive. Within our 2D quanta, the red and black diamonds represent positive and negative charge components, or A2 acceleration fields of opposite polarity. The green and blue triangles represent a magnetic moment, with the A1 acceleration field curling out of the page from green to blue. We can see then that an electrostatic field is constructed from positive and negative charge components as well as magnetic components. The field's net polarity is determined by which color occupies its outer edge. There are always more components of this color than the other in the entire geometry. This diamond geometry has no net magnetic field, as its quanta are tessellated in such a way that its magnetic components cancel each other out. But through the law of interaction, they form the glue that holds this geometric structure together, canceling out the net velocities in the process and making the entire geometry static. In the standard model of physics, electrostatic fields are divergent. In this reformulation, they are technically constructed out of two opposing curling vector fields. But the interaction between separate like polarity diamond geometries, by overlapping them, produces divergent acceleration fields. Only the interaction of one geometry with another is measurable. The overlap of diamond geometries of opposite polarity creates convergent acceleration fields. The other possible tessellation of our 2D quanta creates a magnetostatic field. This geometry has no net charge. The cancelled charge components in this case form the glue that hold the geometry together and make it static. This geometry does, however, have a net magnetic moment. The magnetic components of overlapped magnetostatic fields obey the law of interaction, with similars repelling and opposites attracting. We use this same geometry to describe photons, the discrete packets of energy that superposition to form electromagnetic waves. The difference between magnetostatic field geometries and photons is that photons propagate, in this case, out of the screen towards you. We can construct electromagnetic waves out of photons by stacking them on top of each other, varying the total energy content of them across the stack, as well as the relative orientation of their cancelled charge components. Then have this stack propagate through space. At this point, you may be wondering, if this reformulation of physics is true, why are waveforms not measured to be more triangular? The answer is simple and is related to Fourier analysis. Here we see a photon with its charge components highlighted. The geometry rotates. We'll assume according to a right-hand rule with our thumb pointing up. It also propagates out of the screen. If it propagates much faster than it rotates, we can imagine a scenario where we can view it edge-on as it comes towards us, or equivalently, that the geometry is just moving to the left across the screen. The geometry is constructed from repeating diamond subunits. Each plus-minus pair we equate to being a single unit of electric field. Then, as the geometry moves to the left, we equate the strength of the electric field as being the number of plus-minus pairs stacked on top of each other like batteries in series. We also take the number of repeating plus-minus diamond pairs passing by us per second to be the frequency of the photon. Let's imagine what will happen in the hypothetical scenario where we increase the speed at which the geometry passes by us. If the geometry's speed increases, the width of its triangular signal decreases. Because we measure more frequency units per time, its amplitude also increases. We know this due to Planck's relation here. The energy of a photon is proportional to its frequency. The total energy in this case is the same, but the concentration of the energy in time corresponds to an increase in the signal's measured magnitude. Continuing this process results in the graphical method of defining the hypothetical impulse function, a function of zero width, infinite height, and a total area of 1. Using Fourier analysis and the sampling theorem, we know that we can digitally reconstruct any signal as the weighted sum of time-delayed impulse functions, which means that if our energy quanta are small enough, move and cycle fast enough, while they are discrete in nature, they can create the illusion of being continuous. This effect is compounded by the finite reaction times of real systems due to their inductive and capacitive components. Here we have four special tessellations of our quanta that, as depicted, are unstable and cannot exist. However, if we fold them into 3D tetrahedral geometries, they will be stable and can exist. These form particles called tetraons and are the building blocks of quarks. They're held together by the law of interaction acting between the magnetic and charge components of the quanta. The top left tetraon has a net positive charge as all of its four faces are red. The top right is negative because all its four faces are blue. The two bottom tetraons are neutral as they have an equal number of red and blue faces. We take one negative tetraon and two bottom left neutral tetraons and join their oppositely colored faces according to the law of interaction, we will create a down quark. If we take two positive tetraons and one bottom right neutral tetraon and join their oppositely colored faces according to the law of interaction, we will create an up quark. By joining a down quark, an up quark, and a down quark according to the law of interaction, we will form a neutron. A neutron has no net charge, as of its total 36 faces, half are positive and the other half are negative. We can form a proton by joining the oppositely colored faces of an up quark, a down quark, and an up quark. A proton has a net charge, as of its 36 total faces, 24 are positive and 12 are negative. By once again simply following the law of interaction, we can join a neutron, a proton, and an electron to form a deuterium atom. An electron is formed by magnetically joining three negative tetraons around a common axis. It has 12 negative faces, giving it the same net charge as the proton. The deuterium atom behaves like an induction motor, with the nucleus taking the role of the stator and the electron the rotor. The electron is induced to spin by the oscillating acceleration fields of the quanta, signified here by rotation. We must remember that these quanta are simplified depictions of the essential elements of the geometries of an n-particle system. Furthermore, there are actually far more quanta per phase on these geometries than depicted. By following the law of interaction, we can use the deuterium atom as a building block to construct the rest of the periodic table. Each electron spins in the same direction relative to its nucleus, but to join these two nuclei together, we had to flip the orientation of one of them, so that from this perspective, each electron is spinning in opposite directions. The The spin of electrons is not thought to be a literal physical rotation in the Standard Model. We will justify the interpretation that it is later. For now, we just continue to follow the law of interaction, building up and out symmetrically, coincidentally reconstructing the same progression of orbitals as is in the Standard Model. Let's skip the rest of this tedious process and take a look at the end result, the periodic table 2.0. At the bottom right, we see a side view. Each row is a separate quantum level comprised of different orbitals. On the first, we have S1 and S2. On the second, S1, S2, and P 1 through 6. On the third, S, P, and D. On the fourth, S, P, D, and F, the top half being a mirror image of the bottom. As I previously stated, the orbitals are filled up and out according to the same pattern as the Standard Model. The central figure is a slice of the fourth or fifth quantum level viewed from above. Here's the S1 and S2 orbitals. P 1 through 6, D 1 through 10, and F 1 through 14. There's one huge difference between this periodic table and the Standard Model, and that is that the ratio of neutrons to protons is 1 to 1. In the Standard Model, stable atoms have a ratio of approximately 1.5. This is because in this formulation, neutrons have varying amounts of rest mass in their matter geometries. The neutrons in higher quantum levels have more mass matter than the neutrons in the lower quantum levels. This reformulation still satisfies the experimental observables relating to neutral particle detection because neutral particles cannot actually be detected, but are deduced to exist via applying the principle of conservation of momentum. The rest mass of the neutron in the nucleus determines the base rate of spin of its corresponding electron. The spin of electrons in this reformulation is a literal physical rotation. Electrons have a tiny measurable magnetic field. Charges in motion produce magnetic fields, but in the Standard Model, the intrinsic magnetic moment of an electron is not thought to be caused by actual rotation of charge. This is because, in order to have the necessary amount of quantized angular momentum, the electron would have to spin faster than the speed of light, and it is not possible for matter to travel faster than the speed of light in the Standard Model. In this theory, things are reversed. Quantized angular momentum, specifically as opposed to general angular momentum, is not associated with the rotation of matter, but more generally with the intrinsic rotations of the particles that create our energy quanta. Thus, rotating electrons possess the necessary quantized angular momentum without spinning faster than light speed. The triangular geometries that describe the kinetic energies of matter in motion also possess magnetic moments. Each electron has such a geometry to describe its tangential rotational velocity. The energy of this geometry also describes the energy state of the electron. As I stated before, each deuterium atom acts like an induction motor. Photons can induce the electrons to spin faster, but in order to do so, they must be absorbed into the tangential kinetic energy geometry of the electrons. An imbalance of kinetic energy between the electrons of an atom drives the emission process. We observed before that to join nuclei together we had to alternate the orientation and subsequently the direction of rotation of the electrons, coincidentally satisfying the Pauli exclusion principle. For simplicity, we imagine the electrons to be revolving point masses. If two such point masses revolve in the same direction and speed, the center of their mass will revolve in a circle with them as the central point between them. In contrast, if the 2 point masses revolve in opposite directions, their center of mass will only bounce up and down, the horizontal component of its oscillation being cancelled. This makes the system more stable. It can be made even more stable through the addition of more revolving point masses with different phases, cancelling out the vertical oscillations of the system's center of mass as well. If, however, one point mass was to revolve at a greater speed, the system's center of mass will begin to oscillate more chaotically. In the standard model, the oscillation of charges emits electromagnetic radiation. The same is true in this reformulation of physics. The imbalance of rotational kinetic energy between electrons creates instability and drives the process of emission of that excess energy as a photon. We will soon see that the energy content of these kinetic electromagnetic, or chem field geometries, changes their rate of rotation. Thus, the difference in mass-matter content of the neutrons at the top and bottom of the periodic table also induce instability, and this is the driving factor for radioactivity. You may be wondering, if this theory is correct, why have tetrons not been discovered in particle collider experiments? To understand the answer, we must first learn a bit about how the detection of particles works in such experiments. Particles are detected via the photoelectric effect. If a charged particle impacts a charged plate, it will knock electrons off the plate. In a photomultiplier tube, those electrons then impact another charged plate, knocking off more electrons. This process continues throughout the photomultiplier until a measurable pulse of current is created and recorded as a measurement of the original particle's position. Particle detectors consist of a vast array of such devices, allowing for the tracking of the path of a charged subatomic particle through them. Neutral particles cannot be detected in this way. They are inferred to exist by applying the principle of conservation of momentum to otherwise inexplicable changes in the trajectory of charged particles. A particle collider generally collides two oppositely traveling beams of charged particles at the center of a detector. The particles, in theory, explode into their subcomponents that then travel through the detector and are categorized. The process usually occurs too quickly to produce useful data, so the speed of the particle wreckage is slowed down by scintillator material and a powerful magnetic field. Charged particles moving through a magnetic field will be acted upon by a magnetic force, causing them to travel in arcs. The greater a particle's charge and velocity, the stronger the magnetic force will be and the greater curvature its subsequent path will have. The more mass and velocity a particle has, the greater its inertia will be, and the less curved its path will be. Thus, supposedly unique particles are categorized by their charge-to-mass ratio. By coincidence, tetrons have the same total fraction of an elementary charge as quarks. Furthermore, the mass term in momentum should include both the mass matter of a particle and the inertial mass of a particle's chem field. Thus, through equal charge and variable total mass content, many particles are indistinguishable from each other using this classification scheme, and many supposedly unique particles of the particle zoo are redundant. Up until this point, we've had a completely deterministic depiction of subatomic physics. In reality, all measurements and calculations are subject to uncertainty. The core idea of uncertainty is that we cannot measure the state of a system without interacting with it and subsequently altering its state. Mathematically, this is described by these two equations. The precision that we can measure a particle's momentum multiplied by the precision that we can measure that particle's position is a minimum. The precision that we can measure a particle's energy multiplied by the precision that we can measure the time-dependent variation of that particle's properties is also a minimum. This formulation of physics is also subject to uncertainty. We know that chem fields grow and decrease in odd-numbered jumps, giving a total square number of quanta within them at any given time. Imagine we have a 4 total quanta chem field, but there is uncertainty in its actual state. It could also be either a 1 or a 9 quanta chem field, corresponding to jumps of 3 and 5 respectively. Each state has slightly different total mass and velocity and momentum. Let's compare this to a 36 quanta chem field. If this chem field is also possibly a 49 or a 25 quanta chem field, we can see that the uncertainty in the true state of the 36 quanta chem field is greater than the 4 chem field. If we want the first uncertainty relationship to be true, we need the magnitude of the jumps between the physical sizes of a chem field to be inversely proportional to that chem field's energy content. Or, equivalently, chem fields should be subject to wavelength contraction. It can be shown that they are. We know the repeating diamond subunits of a photon correspond to its frequency. Thus, using Planck's relation, some simple facts regarding equilateral triangles, we can show that the distance between the tips of a photon is inversely proportional to energy. We can calculate various other geometric properties of photons as a result of their energy content. The same process can be done for chem fields, substituting the de Broglie wavelength relation for Planck's relation. We can see that chem fields are subject to wavelength contraction. We plug in realistic values into these equations, we get the unintuitive result that the physical size of things is secretly huge. For example, a visible red photon is approximately 40 meters across. This has important implications for things like the double slit experiment. By shining a light at a diffraction grating, an interference pattern can be created beyond it on a detector. By aiming a particle beam at a diffraction grating, an interference pattern can also be created beyond it on a detector. Measuring the location of a particle just before the grating will give the result that the particle passes through only one opening. And yet, an interference pattern is still created. This result has confused physicists for decades and inspired the creation of many erroneous theories regarding the existence of multiple realities and the interpretation that uncertainty equates to randomness in a particle's state. This randomness can subsequently be used as a justification for the temporary breaking of conservation and causation. Because we have redefined force as being the overlap of different energy geometries, the physical size of these geometries themselves is irrelevant. The centroid of the particle indeed passes through only one opening, but its wave structure is large enough to pass through both simultaneously, interfere with itself, and create an interference pattern. We can also show that chem fields satisfy the second uncertainty relation. For low-energy chem fields, the gaps between allowable energy levels are low, and for large-energy chem fields, the gaps between allowable energy levels are large. Thus, we require the dt of low-energy chem fields to be high, and the dt of high-energy chem fields to be low. First, let's reinterpret what it actually means. Force is created by overlap between energy geometries. Chemfields also rotate, so this overlap must occur in space but also within the same reference plane. The faster a chemfield rotates, the more it will overlap within a given time duration and the more measurements we can take. So we reinterpret dt as the rate at which chemfields accumulate full rotations. To satisfy the second uncertainty relation, chemfields must be subject to time dilation. Time dilation is the phenomenon from special relativity where the progression of time of a frame of reference moving very fast relative to another slows down. We can show that chemfields are subject to time dilation. Chemfields have mass, so we approximate them as a solid mass under constant circular acceleration. Performing some simple math, after substituting a previously calculated energy-dependent spatial property of chemfields, we can see that the radial frequency of a rotating chemfield is inversely proportional to its energy content. Thus, the second uncertainty relationship is also satisfied. These reformulations of uncertainty can be connected to other physical phenomena. If we have a brick of metal with a temperature gradient across it, we can describe the average kinetic energies of its constituent atoms with chemfields. The low temperature or low energy chemfields cycle faster than the high temperature ones. Thus, low energy chemfields accumulate maximal overlaps with the high energy chemfields at a faster rate than the high energy chemfields accumulate full overlaps with each other. This results in concepts like Laplace's equation and the heat equation becoming physical laws as unbreakable as conservation and uncertainty. This is the popular depiction of general relativity's treatment of space-time as a deformable substrate, the deformation of it being caused by the concentration of mass. Regions of high mass or high energy density compress locally measurable space and slow locally measurable time. Conversely, regions of low energy density expand locally measurable space and accelerate locally measurable time. Gravity is formulated as the gradient of energy density. Due to our energy quanta being subject to wavelength contraction, time dilation, and force being created by their overlap, we can see that our reformulation of physics recreates all of these concepts of general relativity. Thus, this theory is a true theory of everything. This theory is called tetraionics and was originally created by Kelvin Abraham, an electrical engineer from Australia. What you have seen so far is a combination of Kelvin's original theory and work that I have done that I believe is an improvement upon Kelvin's original work. Kelvin, within tetraionics, has shown how equilateral triangular energy quanta can qualitatively model all of physics. I have shown how these quanta could be a phase space representation of a nonlinear n-particle system, as well as how the quanta can be subjected to wavelength contraction, time dilation, and uncertainty. You may be wondering that if the properties of these triangles is just a coincidence. I argue that if it is, it's one of the biggest coincidences in the universe. As far as anyone can tell, electric and gravitational fields distribute energy throughout space continuously. So if we were to use a single fractal geometry to completely describe energy, it must at least perfectly tile all of 2D space. There are only 3 possible geometries that can do that: squares, hexagons, and equilateral triangles. Of those 3, triangles just happen to create everything you have seen here. I think it unlikely that they would do so for no reason. If tetraionics is true, then there are many different applications of it that, if they could be created, would be incredibly useful. In tetraionics, physics is fractal. Quantum systems and macroscale systems have the same fundamental properties and are subject to the same laws. A single quanta is constructed from oscillating electric and magnetic fields and has a net average velocity. So, perhaps we could create a scaled quanta or distribution of oscillating electromagnetic fields that we could use to bounce off of the intrinsic electrical properties of vacuum or some other medium. This is a hypothetical electromagnetic drive. I have not tested it because I don't have enough money to prototype it, though I would like to. These are 2 magnetically levitated disks of alternating magnets. These half-arcs are the stators of a DC brushless motor system. They are used to spin these disks of alternating magnets very quickly. So quickly that the alternating magnets spinning past this metallic frame induce a traveling electromagnetic wave down it and a force against it like that used by magnetically accelerated trains. The force will also be transmitted down the frame here and inward along here. But as it's projected at an angle, it won't completely cancel the vertical component of force here. I'm not sure if this device will work. There will be a reaction force against the spinning disks, but there's something odd going on here, and I don't think the net result is at all intuitive. Each disk creates a torque on the center that superpositions into a linear force. The reaction force on the disks is really a reaction torque. Since these disks are free to spin, it seems to me like this will simply manifest as a resistance to acceleration, or damping on the system that could be continually overpowered. We can also imagine what would happen if instead this central column was an accelerated bullet, tied via a wire to a tripod and frame holding the spinning disks. This harpoon-like bullet will accelerate freely until the wire becomes taut. If tied to the tripod in the right spot, and if the tripod is light enough, the bullet will yank the tripod over and technically displace the system. The real difference between the fixed central column and harpoon central column is that the harpoon case concentrates the transfer of momentum into an impulse, thereby overcoming the inertia and static friction of the system. With the correctly shaped and timed fields, I think it should generally be possible to travel through a medium by continually bouncing off of its inertia, like these geniuses demonstrate within this video. This is an Einstein ring. It's created by the path of light being bent by deformations in space-time created by gradients in energy density throughout space. Because tetraionics reformulates gravity as a blurring together of many different electromagnetic interactions, perhaps we can bend the path of light using an electromagnetic field. We'll use the phenomenon of dielectrophoresis as inspiration. This blue vector is a curved electric field. This is a water molecule. Water is polar. It has a positively charged side and a negatively charged side. The positive half will be accelerated parallel to the electric field. The negative half anti-parallel to the electric field. The net result is to cause the water to conduct perpendicular to the curved electric field. This effect has been studied and applied by scientists in the fields of microfluidics and digital microfluidics for decades. We know photons have separate magnetic and charge components. If tetraionics is true, it may be possible to create a curved electric or magnetic field powerful enough to deflect the path of light. If the creation of such a field effect lens is possible, it could be used for interstellar flight. Simply travel toward a star while diverting light around your craft. The gradient between the high energy region of the star and your created shadow will induce a gravitational force that will cause you to bounce off the star. The geometries involved being very reminiscent of the concept of a wormhole. This device, however, is incredibly dangerous. You might create gravity so strong that you will spaghettify your ship. You will also pull on the star, which after you accelerate away will collapse back inward. If you do things wrong, possibly creating a black hole or exploding in a supernova. There is a phenomenon known as sonoluminescence, whereby vibrating water with sound waves in a megahertz frequency range will cause collapsing cavitation bubbles to emit flashes of light. Kelvin proposes that the mechanism for this phenomenon is a gravitational electromagnetic pinch, or GEM pinch for short. We know that matter is constructed from EM waves. It may be possible then to superposition an electromagnetic waveform over top of it to destructively interfere with the forces holding it together, thereby releasing all the energy within it matter as electromagnetic radiation. This would effectively create antimatterless annihilation. If realized, this could become an effectively limitless source of clean energy, or possibly a horrifying new weapon of mass destruction. I believe I've discovered one possible device design that could create a gem pinch. This also has not yet been prototyped due to a lack of money. This is the frame of the device. It consists of a multitude of radial arms. That have solenoids wired across them such that the current curls in one direction on one side of the device and the other direction on the opposite side. These will create a magnetic field that curls like this. We know from Maxwell's equations that a curling magnetic field will create a time-varying electric field, denoted by red. Due to the device's symmetry, it actually induces a curling electric field. Which by Maxwell's equations again will induce a time-varying magnetic field. Due to the field magnitude's inverse distance dependence, there are additional points about which the induced electric field induces another magnetic field. These additional magnetic fields will oppose the starting magnetic field, but the iterative curl operations reduces the induced field's magnitudes such that they do not completely cancel out the starting magnetic field. This fact, and their time-varying nature, causes the starting electric and magnetic field's magnitudes to ripple. In theory, it is possible to design the device's time constant such that the resulting waveform has a specific frequency content. A polar molecule, such as water, when placed in the center of the device, will experience opposing forces on its positive and negative ends. Positive charges will be accelerated with the induced electric field, negative against it. Charges moving through a magnetic field will be acted upon by a magnetic force, obeying a right-hand rule for positive and a left-hand rule for negative. This means that negative charges will be accelerated away from the device's interior and positive toward it. This creates a force distribution similar to the tidal gravitational forces surrounding a black hole. At high enough energy densities, this device might be able to tear subatomic particles such as tetraons apart, thereby creating a gem pinch. Considering the acoustic energy densities of sonoluminescence are only on the order of millijoules, this device may be viably constructed from consumer-grade electronics. Over the years that I have spent working on this theory, I have noticed something peculiar. Many of the geometries within it look familiar, and this is because they often appear in religious iconography all over the world, often in stylized form. On the right is the Sri Yantra mandala, signifying simultaneously all aspects of existence. On the left, the 3D periodic table viewed from the side. The periodic table represents all elements that the universe is made of. At the top is a drawing in the sand at Nazca, Peru. The bottom highlights the mandala pattern in black. Note the repeating diamond subunits. These are simplistic patterns and could just be the result of coincidence, but consider the religious context of the symbols. Wherever tetraonic likenesses are found, they are often accompanied with the context that the symbol is sacred, has sacred knowledge encoded within it, and it was given to humans by a higher being. I have no idea whether or not this is true, and I'm not claiming it is. It's just interesting food for thought. Freemasons in particular have numerous symbols reminiscent of tetraonic geometries. For example, this, the triangle with the all-seeing eye of God looking out of it, whom Freemasons often refer to as the Grand Geometer. You may be wondering, if this theory is so amazing, then why have I never heard of it before? Why doesn't it get more attention by mainstream academia? The answer is that even without invoking the idea of a large-scale conspiracy, there's a great deal of incentive for the scientific establishment to see this theory swept under the rug. If it's proven to be true, it shows that some very prominent physics institutions and organizations have essentially been wasting their time and money on performing ever larger, more elaborate, and expensive particle collider experiments for the last 70 years or so. This is because of the whole variable mass matter thing, and the idea that this theory shows the vast majority of particles discovered as part of the particle zoo are redundant. They're not unique, nor do they serve any actual purpose in the construction of physics. They're just a small subset of unique particles with varying amounts of mass. This is a huge deal because many of these institutions get funded at least in part by democratic governments, which are made of politicians who must appease voters in order to get re-elected and maintain their career. The general public found out that the scientific establishment had effectively wasted billions of dollars of public funding. They'd probably not be very happy, and the government would have very little incentive to renew the funding for these institutions. I have personally interacted with people who dislike this theory, not because they believe it is wrong, but because they are very certain it's true. Considering the wide-scale amount of good applications of this theory could do across the planet in terms of limiting or even completely stopping climate change, among many others, it's my opinion that these people who would seek to sequester the truth are traitors to our entire species. You may have noticed a conspicuous absence of n-body simulations for things like electrostatic fields and matter. This is because I've not yet gotten simulations of those things to work properly. This obviously calls into question the validity of almost everything you've seen in this video, but I don't think things are as bad as they may appear. The first reason is that understanding how nonlinear systems like n-body systems work is just incredibly difficult. Some people spend their entire academic careers on the subject, and the use of phase flow diagrams is a common strategy to gain valid qualitative information about the behavior of nonlinear systems. The second reason is that computational simulations are subject to a large amount of limitations and problems of their own, such as the slow accumulation of error and the need for finding the correct non-dimensional parameters that actually create a valid solution over a limited range of the system's state variables. In the case of this n-body system, the biggest problem is that what values these alpha constants are actually supposed to have is unknown to me. By guessing random values, I got lucky and found ones that constructed a stable conical solution. But those values only work for a particular time step and initial conditions. If you wanted to conduct an accurate simulation with different initial conditions or a different time step or spatial resolution, you'd have to change the values of these alpha constants or the relative strengths of the acceleration fields to something else. This creates a very inconvenient situation where other stable solutions probably exist and may include all of the geometries we've previously seen recreate all of physics. The phase flow interpretation of them, at least, does make sense. But obviously, sitting around and just trying random values is a very inefficient way of trying to find those stable solutions. This is a job that is better suited to being automated via a machine learning or AI program and run on some kind of supercomputer. Furthermore, this is something I am incapable of doing because of the limitations of the hardware on my laptop. This simulation of 12 particles takes about an hour to run on my laptop. So simulating something like a deuterium atom consisting of hundreds of particles is completely infeasible. There are ways to accelerate the computation process by either parallelizing it across multiple processors or by having it instead computed by GPUs, but I don't currently have the necessary skills to do that, and I am unable to work on this full-time due to financial constraints. I graduated from university in 2017 with an engineering degree, but have only been able to work in non-technical minimum wage jobs since then. My career prospects have definitely suffered because of my association with this theory. If this theory is proven to be true, it could completely change the world for the better, and so if you'd like to help me make that a reality, I'd like to ask a small favor from you. Simply upvote this and share it with whomever else you think might find it interesting. There are many improvements that could be made to this theory, and the application of it where it might take a lifetime to stumble across the small bit of useful information that allows me to make the leap of discovery, but someone else might already have the prerequisite skills, knowledge, or resources to allow them to do it much faster.